Stage 2 and cools rapidly.
This rapid change drives the next phase of evolution. The universe has begun to expand from a dense, hot point. As it expands, the universe cools rapidly, allowing matter to form.
Welcome. Today we are diving into, well, the biggest story you can possibly tell. The story of everything. We're talking about our universe, from its absolute first fiery second all the way to our modern-day quest to figure it all out. You know, if you really want to understand our world, or our solar system, or even ourselves, you've got to go back. I mean, all the way back, right to the very beginning. So, picture this. The universe is born in this unbelievably hot, dense state, basically a brilliant cosmic fire. But the real story, the part that truly shaped everything we see today, well, that happened in the critical moments right after. So yeah, let's get into it.
It's kind of wild to think about, but those first 3 minutes, I mean, that was it. That was the period of incredible chaotic change that literally set the stage for the entire future of the cosmos.
So, as the universe is expanding at this mind-boggling speed, it's also starting to cool down. You can imagine it like a brilliant white-hot fireball that, as it stretches out, dims to orange, and then to a deep, deep red. The bigger it got, the cooler it got.
But inside that cooling fire, oh, it was just pure chaos. We're talking a turbulent, trillion-degree soup of the most basic particles you can imagine, things called quarks, just bouncing around like crazy in a sea of energy. It was way, way too hot for anything stable to form. And then, everything changed. In a tiny fraction of a second, the universe cooled just enough to hit a critical temperature. And trust me, a monumental shift was about to happen. So, the moment the universe dipped below 1 trillion degrees, the strong nuclear force, one of the fundamental rules of nature, it could finally take over. It basically just grabbed all those free-roaming quarks and locked them together, forcing them into the very first stable particles we know, protons and neutrons. And right there, for the very first time, we start to see structure, some kind of order emerging from pure chaos. And this timeline, man, it just shows you how unbelievably fast all of this happened. Think about it. At just 1 microsecond old, the universe already had protons and neutrons. By the 3-minute mark, this super important creation phase was in full swing. But then look at that huge jump. It took another 380,000 years, a long time, for things to cool down enough for the first complete atoms to form. Okay, let's zoom in on that 3-minute mark, because this is huge. This short, but absolutely critical window of time is when a process called nuclear synthesis essentially cooked up the raw ingredients for, well, everything that would come next. You could say the cosmic recipe was written right then and there. And you know what's wild? The recipe was ridiculously simple. First up, hydrogen. About 75% of all the normal matter in this brand new universe, yep, it was hydrogen. And the rest? The other 25% was helium. That's it, just those 2 simple elements. And with that, the universe had its complete starter kit, the building blocks for everything that was about to happen. Stars, galaxies, and, well, eventually, us. But here's the thing. Even with that recipe written and all the ingredients ready to go, the universe wasn't quite ready for the main event. You know, stars and galaxies. First, it had to go through this long, dark phase. Think of it like a cosmic waiting room. So for the next couple 100,000 years, the universe was kind of stuck. It's a period we call the cosmic dark age. The whole place was filled with this thick, soupy fog of plasma. And the big problem was all these free-floating electrons just zipping around. They acted like a cosmic net, trapping any light, any photons that tried to move. So, yeah, it was completely dark. Nothing could shine through. So basically, all that hydrogen and helium that had just been created, it was just hanging out, suspended in this total darkness. It really was like a waiting room, with all the parts assembled, just waiting for the universe to cool down just a little bit more. And then, finally, after 380,000 years of sitting in the dark, the universe hit its tipping point. The great ignition was about to happen. It was time to, well, let there be light. So with the fog lifted, the universe was now transparent. Light could finally zip across the cosmos for the very first time. And this cleared the stage for another major player to take over, gravity. Slowly, so patiently, over hundreds of millions of years, gravity started to do its thing, pulling those huge clouds of hydrogen and helium together into bigger and denser clumps.
And folks, this is how it all began. This is how everything we see out there today got its start. Those clumps of gas got so dense they ignited into the first ever stars. Those stars then grouped together into the first galaxies. But the story doesn't end there. When the biggest, most massive stars died, they went out with a bang, exploding and scattering all these new, heavier elements across space. And those became the raw materials for the next generation of stars, and, for the first time, planets. It's this incredible, beautiful cosmic cycle, birth, death, and rebirth, happening on a galactic scale.
Okay, let's fast forward billions of years. That cosmic cycle of creation leads to something, well, pretty extraordinary. On one little rocky planet orbiting a pretty average star, something amazing happens. Consciousness emerges. And what do? We start looking up and looking back, trying to piece together the very story we're telling right now, the story of where we came from.
And this quote, it just nails it, doesn't it? That deep-seated human curiosity, that simple desire to take a look around the corner, that's what's driving us. It's why we explore not just our own planet, but our entire cosmic neighborhood. In one of the corners we are peeking around right now is the actual edge of our solar system. Turns out we've discovered that we live inside this huge protective bubble. It's called the heliosphere. It's created by the solar wind that's constantly blasting out from our sun, and it acts like a shield, protecting us from a ton of nasty cosmic radiation coming from the rest of the galaxy. So, what do we do when we find a corner? We go look! So we send a probe, of course. Missions like NASA's IMAP probe, that stands for Interstellar Mapping and Acceleration Probe, are heading out to that exact boundary right now. Their mission? To study what some scientists have called a cosmic zoo of exotic particles that are hanging out just beyond our bubble. It's all about understanding exactly how our sun keeps us safe.
And you know, our tools for this epic quest are just getting better and better. They're becoming so powerful they let us peer deeper into space, which also means we're peering farther and farther back in time than we ever have before. I mean, look at this. We've built this incredible fleet of instruments, and each one is designed to solve a different piece of this giant cosmic puzzle. You've got the Hubble telescope, which shows us the visible universe in breathtaking detail. Then there's the Webb telescope, which is like a time machine, using infrared light to see the very first infant galaxies. Back here at home, IMAP is sniffing out our protective boundary, and missions like TESS, they're out there hunting for new worlds orbiting other stars. So this entire journey, all the way from the Big Bang to the telescopes we're building today, it all funnels down into one single, staggering question. I mean, NASA has now confirmed over 6,000 planets outside our solar system, so we're closer than we have ever been to confronting what might just be the most profound, most haunting question of all.
Thank you for following the mysteries of the universe with us.
Next, stage 3, quarks and leptons appear, the fundamental particles like quarks and electrons.